You know, one of the things that we did in class the other day was to do timing, count what we call oscillations. We are doing 20 oscillations and getting the time and then calculating the period. We're going to see the same here, but this time, as I said, using an animation, using this program, and what we shall look at is the energy changes that do take place when a pendulum swings from the maximum ends, which we call A and B, and then the rest position, which we call O. So here we are. You can see there is a ruler. Are you seeing here a ruler? Yes. Which is here already. Just the length of this string. We can change in this window here. We can change the length we want. We can change the mass. Here the length has been set to be 0.70 meters. That's about 70 centimeters. We can introduce a stop clock by clicking here. When we click here, a stop clock comes in. It's going to help us to count when we want. For example, let's say if we change the length here, maybe 90, that's 80. We're going to do it to 90. Are you with me? So when we swing, and the mass, you can see the mass which is here. There are two masses here. We can reduce the mass by putting one only. Can't do what I want to do. But we can change, but you know the mass has no big change in here. So when we swing this, it's up to us to decide the angle. Maybe we put it at, the angle should not exceed 20. So when we do that and leave it, you can see it is swinging the way we are doing our work. Are you guys getting? So now to count the oscillations, we start from one end. For example, when it's there, that's when we start the counting. And then we count the number of oscillations. We want to count 20, and then we will be able to get that. When you want to stop, you stop here and to stop swinging. Are you getting it? Yes. So we want to get time for 20 oscillations. So we're going to change that. I want us to set it to 20. I always don't want it to exceed 20. So we'll set the angle to 20. Then when it is at one end, I'm going to say start. And then we shall count 20 oscillations. So here we go. In 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then we stop. How much time? The time is here. How much time is that? Pardon? 38.11 seconds. But remember when we're in the lab, we're using a stop clock, not a stopwatch, where we are writing only one decimal place. So here, to round off to all numbers, this will be 38 seconds. Are you guys with me? Of course, it doesn't stop swinging, it will continue swinging. But we want to see, have you guys, so can we draw a simple table, and we shall put L as being length. So we want our tail to have length L And of course the length is in meters. Then we shall have the time in what? In seconds. After we do that, we shall calculate the periods, and we shall also calculate the square of the period. Now, we shall keep the integrity. I think, what's the length there? What's the length of our string? 0.90 meters. So we are going to do this for about 6 values: 0.80, 0.70, 0.60, 0.50, and maybe 0.4. And for each of these lengths, we shall get the time for 20. So we know we say our table should be closed, and we shall close it. So, you know, one of the things that we did in class the other day was to do time